Assalamu alaikum to everybody. Today we will discuss a very important topic that is called the pressurization of an aircraft. And normally the pressurization is achieved in the modern airlines that are flying at higher altitudes. And we will also discuss the safety devices and the indicating systems that are available to the crew inside the cockpit while the aircraft is being pressurized at higher altitudes. Up to an altitude of 10,000 feet, there is sufficient amount of air pressure and oxygen that is available for the crew and the passengers to operate normally. However, at altitudes above 10,000 feet, it is a regulatory requirement for the cabin pressurization to be able to produce a cabin altitude of 8,000 feet at higher altitude. In a modern aircraft, the maximum differential pressure set by the manufacturer is normally between 8 to 9 psi. This maximum differential pressure, along with a maximum cabin altitude of 8,000 feet, will set the maximum operating limit of a particular aircraft. As we know, according to the chart, that the absolute atmospheric pressure at 8,000 feet is 10.91 psi. And for example, the limit set by the manufacturer of maximum pressurization is 8.2. So what we will do is, we will subtract 8.2 from 10.91. That means this is the atmospheric pressure at 8,000 feet, and this is the manufacturer's maximum pressurization limit of the aircraft. So the answer is 2.71. From the graph, we check that 2.71 is just a touch above 40,000 feet. So that means an aircraft maximum pressurization limit, which has 8.2, can fly up to altitude of 40,000 feet. However, there are more limitations that can be imposed while climbing at 40,000 feet. If for any reason the aircraft is not able to maintain a differential pressure that it was maintaining, for example, the earlier differential pressure the aircraft was maintaining was 8.2 psi and it has dropped to 6 psi. Now the aircraft has to fly at a new altitude. Obviously, it has to descend. Now we will check that what is the new altitude the aircraft should fly. So we will subtract 6 psi from the pressure of 8,000 feet, that is 10.91, and the answer is 4.91. From the graph, we can check that at a pressure of 4.91, the aircraft can now fly at around 27,000 feet. Cabin pressurization is achieved through entering a mass flow of air inside the cabin through the air conditioning system. The supply of air is achieved through the packs and it is released from the outflow valves. If these outflow valves are closed, that causes the cabin pressure to increase, that causes the cabin altitude to descend. And when the outflow valves open, that decreases the cabin pressure and it causes the cabin altitude to climb. In emergency depressurization, the dump valve is operated manually. And the ditching control system closes all the safety valves in the event of an emergency landing that reduces the flow of water that can come inside the cabin in an emergency landing. So today we learned the complete system of pressurization in a modern aircraft and hope to see you soon, inshallah, coming up with new lectures, and thank you for watching and your time. Allah.